Okay, so our topic, next topic is diffraction. Diffraction is very interesting and is quite interesting. So diffraction has to do with the idea of waves. So when waves meet a gap in a barrier, they carry on through the gap. However, the waves spread out to some extent in the area beyond the gap. This is diffraction. So I will illustrate diffraction when like this. So let's draw. So if we have a barrier right here, but we have a hole right to the middle. So we have a hole right there, right through the middle, and a sound wave. So I'm going to use blue as waves. So this is what waves look like. These waves could be anything. They could be like they're usually sound waves. So when sound passes through something else, then it goes through. So we see the sound waves. They go through the barrier, through the small hole, and then they extend out. So like this, they curved, extend out, bigger and bigger and bigger. So that is differentiation. So the extent of the spreading of the after it passes through the barrier depends on the width of the gap here. So if this gap is narrower, it causes a lot of spreading with no sharp shadow. So for example, if you heard a sound through a doorway, but a gap that is larger than the wavelength causes little spreading and a sharp shadow. For example, light going through a doorway. So the larger the gap, the less spreading. Okay, so different can sometimes be seen in waves in the sea when they pass into a harbor, and there are many places where we can see diffraction, like when we hear someone speak but we can't see them. That's diffraction, as the sound waves are traveling through the air through holes and trying to get through us, and they spread out. So that's diffraction. Yep, nothing else to do.